Hello, Year 12. So we've got a period of learning from home. So the way we're going to do that, because we've got 3 lessons this week, is I'll make you a video where we'll talk about a topic. We'll go through some explanation, a couple of examples, and then I'll set you some questions to do. And I should be able to put that on Teams on the day of each lesson. So hopefully you can do it during our 1 hour lesson slot. And then during the lesson itself, I'll start a meeting on Teams. You don't have to join that, but I will be in there. And then if you do have any questions, or if you just want to say hello, you can drop in to the meeting and you can ask me whatever it is that you're doing. And hopefully I can help you out with that. And it should work quite well, because if you just drop in sort of ones or twos, or even just ask questions on Teams or by email, then it will be a bit more personal, because I did some live lessons last year with the last lockdown and I didn't think they went too well because it was too tricky to get interaction and engagement. And there was too much opportunity for things to go wrong with internet disconnections and people missing it. So I think with these recorded sessions they will work a little bit better, in terms of people will be able to do them when they like, and hopefully be able to get some more sort of individual help if they need it as well. So we'll start what we're going to do today, and then what's going to form a sequence really of hopefully 3 lessons that will take us through this week. Okay, well, we're going to look at the binomial expansion. It is a topic that we looked at before Christmas, in fact, in the very first half term. We do need to go a little bit further with it. So for today's lesson, we're just going to recap what we looked at before. So the binomial expansion, well, a binomial is a collection of 2 terms, the bi part meaning 2. In one or more variables. So in this case our binomial is 1 plus 2x, and we're expanding it because we have 1 plus 2x to the power of 5. So we're going to work out this binomial expansion, and then for the first example we're going to look at using our expansion to find the value of 1.2 to the power of 5. So I've put up in the top right hand corner, this is the formula for binomial expansion. You are given this in the formula book. So here your binomial is a plus b to the power of n, and you can see that it will be a to the n plus, now this column vector here is actually your NCR on your calculator. Hopefully you remember doing that, and that will give you the half term of the nth row of Pascal's triangle. So if you remember, we were looking up values in Pascal's triangle when we were doing this before. So what's going to happen is, it's quite nice because it forms a sort of symmetrical pattern where you have a to the n, then a to the n minus 1, then a to the n minus 2. So the powers of a are increasing. Likewise, at the same time, the powers of b are increasing. This first term has sort of like a b to the 0, b to the 1, b to the 2, and so on. And so we'll sort of just have a look at how this one works, and I'll just remind you of it. So for part A, we know that 1 plus 2x to the 5 is therefore going to be, and if we just look at the formula, it's going to be 1 to the power of 5 add, and then it's going to be 5c1 times 1 to the 4 times 2x add 5c2 times 1 to the 3 times 2x squared. Now I put in brackets here to remind you that when we do the 2x times squared, it will actually be 4x squared. So we'll keep going. The pattern is hopefully quite clear. 1 to the 2, 2x to the 3. One thing to point out just as we're doing this is in each term the powers will add to make 5. So you've got 5 and 0, 4 and 1, 3 and 2, 2 and 3, and 5 importantly is the power of our original expansion. That will be important for other questions. 5c4 times 1 to the 1 times 2x to the 4 And then the last term would be 5c5, but that will just be 1, in the same way 5c0 was. 1 to the 0, which will just be 1, and then we've got 2x to the power of 5. So that's what it's going to look like. So now if we work this out and write it in ascending powers of x, you can see that the first term is going to be 1. Now this is going to be the first term on the fifth row of Pascal's triangle, so it's going to be 5 times 1 times 2x, 10x. And then we've got 10 times 1 times 4x squared, which is 40x squared. And as I say, use your calculator if you're not sure here. 5c2, you need to use the NCR button, which is probably shift and then divide. And then we've got 10 times 1 times 8x cubed, so that's 80x cubed. And then we've got 5 times 1 times 16x to the 4, so that's 80x to the 4. And then we've just got 32x to the 5. So that's the first part done. That's our binomial expansion. You may have to work out all of the terms, or if it's a larger power, you might just have to work out the first 3 terms or something like that. So part B is how we can actually use this binomial expansion. So we know that 1 plus 2x to the 5 equals 1.2 to the 5 when x is 0.1. So if we take our expansion and substitute in x as 0.1, then we'll get our answer. So we know that 1.2 to the 5 is going to be 1, add 10 times 0.1, add 40 times 0.01, add 80 times 0.001, add 80 times 0.0001, add 32 times 0.00001. So what's that going to be? It's 1, add 1, add 0.4, add 0.08, add 0.008, add 0.00032. And so we can just add those together then. So I'll just do that on my calculator. 1, add 0.4, add 0.08, add 0.008, add 0.00032 is 2.4882. Now I've just been a bit lazy at the end there. The whole point is that you could do this without using a calculator, and I could have just lined them up and added them, but just to save a little bit of time, I've done it like that. And if we just check by doing 1.2 to the power of 5, we can see that we've got the correct answer. So our next example is this one. We're going to do 2 examples just so we've seen the sort of rough mix of questions. And then I'll just give you some practice today really on what we've done before. So for this one, we need to find the first 3 terms in the expansion of 1 plus qx to the 8. So just like before, we know that 1 plus qx to the 8 is going to be 1, and in fact 1 to the 8. And then it would be add 8c1 times 1 to the 7 times qx, add 8c2 times 1 to the 6 times qx all squared, add ... So there would be in total 9 terms, because you'd have the constant term and then 8 different powers of x, but we only need the first 3. So that's going to be 1, add 8 times 1 times qx, add, now for this one I will go for my calculator, 8c2, which is 28, so it's going to be 28 times 1 times q squared x squared. So don't forget that one. Lots of people will forget to square the q here, so make sure you're not one of those people. So part B then says, given that the coefficient of x is minus r and the coefficient of x squared is 7r, find the value of q and the value of r. Well, the coefficient of x is 8q. So we know that that's not a very good q, 8q equals minus r. And we also know that 28q squared equals 7r. Okay. So we need to then find the values of q and r from this. So we can just solve these simultaneously. So what might we do? We may times the top equation by 7 on both sides. So it becomes 56q equals minus 7r. Now we can add the two equations together and we see that we get 28q squared plus 56q equals 7r add minus 7r, so equals 0. And then we can factorize this to solve it. 28q times q plus 2 equals 0. So q could be 0 or minus 2, but it says here that q is a non-zero constant. So q is negative 2, and so we can then see that if q is negative 2, we get negative 16 equals negative r, so r is 16. And that's that question done. One thing that people do sometimes mess up here is when it mentions the coefficient of x or the coefficient of x squared, you don't actually need to have the x's in this line of working. So if it's referring to just the coefficient of x, that's simply how many x's there are, so 8q, that you don't still need the x's. You could write 8qx equals minus rx, but you would just cancel the x's out, so that's kind of pointless anyway. So that's it. That's our two examples done. We're going to do a few sort of similar questions just to recap today, but as I said, we're going to go quite a bit further with this. So I'll stop this one here. I'll put the questions up, and the questions will be on a separate worksheet, and I'll send you the answers as well.